Welcome to another stream. Yeah, I thought I was just gonna do some more streaming, working on the live coding tool. I have made a lot of progress, actually. I hope I'm sounding alright, because I'm in a very hollow room, and because like it's fully empty. Oh, it didn't do the beginning. It is working, it did do the beginning. Sorry, I'm gonna redo that start. So, hi, welcome to this stream. I thought I was just gonna do some working on the live coding tool on the stream because it's fun to do. I really liked it last time. I'm in a very hollow room and it's very noisy. I hope that it's not too bad. I have a microphone and I try to put some noise cancellation around it, some ASMR, and around my keyboard, so it's a bit better, but yeah, it is gonna be quite noisy. Oh, hi Brian, I see the chat. Let's see, like last time I didn't really understand everything. I made it so the chat doesn't disappear anymore. So that will be better. Okay, so since last time I've made a lot of progress because I've had some food poisoning, which is very bad, but so I couldn't really stream, but I could program in between other things I was doing. So it is a lot further than last time. I'll just start it. Oh no, it's opening on the left one again. I wonder why that is. So okay, I'm first quickly gonna do the thing where I'm gonna win.setPos. What was it? Minus 2000 and minus 900, something like that. Wow, look at that. Okay, so, oh, sorry. Here is the tool now. It's still some text, but now everything works. I'm drawing these things, that's just for debugging. I'm gonna remove that real quick. I'm doing that in the draw function. Yeah, here. That needs to be gone. Okay, so you can just do enters and you can, I really like this feature from normal editors. If you hold Alt and you move, then you're scoping to interesting places. So it ignores normal characters and underscores, and it'll scope to more important characters, which really helps moving through lines. You can swap lines, which I also really like from other editors. And you can even swap characters. That's not a feature I've seen before. But I thought like in these languages, everything is very concise, and being able to swap individual characters is going to be very handy. And it was just a fun thing to make. So yeah, I've gone quite far. I've gotten quite far, and it's all running quite stable now. So to start off with, I think I'm just gonna first go through what I did to make this happen. Okay. Mic sounds great. Oh, nice. So the audio is great. Yeah, I've got a microphone. I got it. Oh, sorry. I got it for I think 70 euros only. It sounds very good. Yeah, let's go through it. So one big thing I changed, and Brian already knows this, is I have separated, because I was talking about. Wait 1 second. I'm gonna open this up a bit. Oh, it's already open. Never mind. I was thinking about the idea of, I did a lot of modification last time within the class. I don't know how you call this. This is like, or actually this. I call it a closured namespace because that's essentially how BQM would call it, I think. Because it's a namespace since it returns functions, and it's closured since it holds some values. But in other languages, you would just say it's a class, I think. So in the last class, I did a lot of modification to like internal modification, because I said like, oh, yeah, your code behind my. Oh yeah, I'm sorry. I need to. That's a good one. I need to do this. Yeah. Okay. Hello. In the last version, I did a lot of modification within the class, but now I made this TextEditor pure. And I made it so you can use these pure functions to get the behavior of the way the text editor works, and then you hook it up to whatever context you want, and there you do modification. So so here actually only in React it's gonna do a lot of these things, and that's like a more messy part where you do a lot of modification. And in this function, everything is just getting the text and the cursor and then returning a new text and the cursor. And it's not using any outside variables, and it's always given the same input, you get the same output. So it's like pure and functional. Yeah. There we go. Nice. Okay, I'm gonna just run through it. Sorry, Brian, because I think you already know lots of this stuff. Maybe not. Maybe it's still interesting to go through. So typing a character, that's the most basic part of a text editor. So as I said, I'm gonna give each function the text and the cursor. The text is, last time I did string of strings, or a list of strings for each new line. And I already said, like, I moved to this from the idea of matrices or table in BQN. Because it was like the matrix, I thought it was very good because BQN works very well with multi-dimensional arrays. But I brought it down but that got too many problems, because you need to always make it a square. It needs to not be ragged. So then I did a list of lists, which I thought was that's more a step down to more a simpler form. But then I got too many problems in that. So now I moved down to the idea of the /n. So one long string separated with a certain character. And the character I use is actually this lovely character for a new line. Because then if I interpret it as BQN, it's just gonna do new lines on the new lines. But in the editor, it's gonna do an enter when it reads a new line. So if I'm now typing a new line and it's doing an enter, but that's fine, you just can't use new lines now. So it's a string separated with new lines for enters. And in type, you're just gonna give a char. I'm not sure how much I should go through all the specific code. But yeah, here just rotate it so the current position is in the start, and then you add the character, and then you rotate it back. And then you move one to the right. That's quite simple. Backspace, you don't have to give anything because it just removes one character. And I stopped doing the reverse version of type because I think it's a bit gimmicky. I don't think it's explicit enough. Yeah, this is a bit annoying, but you need to watch out for the case where you're at the start of the line. If you start, you can't delete anything if you're on the left. And then you're just gonna, again, rotate to the position, drop one, and then rotate back, and then move on to the left. That's all. And one problem I had here was I was moving to the right afterwards, but when you were at the very right, you typed the character, then it didn't know that there was a character yet. I was still using the normal input, and then it didn't know there was a new character. So it was just not going further because it thought it was the limit. But so now I use the new value. Okay. A tab is typing. Now it's actually one character. It should be. Anyways, it's. I'm gonna fix that. And enter is typing an enter character. Then you got the swap behavior. The swap behavior is what I showed you. The swapping lines and swapping characters. Yeah, it's just grabbing two things, so or one down or one up, and then swapping them around and then placing them back. So, and there are some edge cases, like when you're on the edge, you don't want to do it. When you're on the left, you don't want to do it. Otherwise, you just swap right, swap left. And move to the new position. And here as well, you're seeing if the target doesn't exist. Okay, if you're swapping to nothing on either side, and then you just swap the lines, right or left, which doesn't make sense in that case. But if you look at it from the list of lists or a list of strings, then it does make sense. Yeah, and then you're moving the cursor. That was a big thing. After you swap the line, your cursor is still on the last line, And because the size of the lines don't align, and normally this C means the index on the whole string with all the characters in between. And you always, that's the problem with it. If you go up and down, like here, you need to retain the position it was in. And even when you're on the right, you need to go to the end of the last line if it's too long. And this sort of space, this up and down space, doesn't exist in this long string. So you need to sort of calculate, like split it up, see what lines are underneath each other, and then go to that position. And if you swap lines, then the whole index you had is going to be totally different because the last line is longer. So you need to like change it and then go over. Well, it's a bit hard. That's what I want to say. So I have this function to get this from an XY position, a cursor position, or from a cursor position and XY position to like transform between this space where you have new lines and this space where you have the one big line. Okay, then you've got the scope function. That's what I showed, where you go to interesting places. You scope out the interesting places. So I've got some characters which are interesting, and you give that at the start. This whole thing generates this whole string of letters, and then 2 special characters which I add at the end. And then it just ignores those and scopes to interesting characters. Bounds just goes to, I didn't show that, I think. If you hold an Apple version command, and in Windows you would do home and end, you would go to the end and the beginning of any line. And if you go up and down, you would go, oh, that isn't working actually. Good to know. You go all the way down, like page down, that's equivalent to, and page up. Page down actually goes down like a certain amount of lines, but this just goes all the way down. That's what bounds are for. You think of it like the bounds of the program, or of the page. You got move, where you move the cursor. And this is just limiting, so it doesn't go too far, like outside of the whole screen. And the nice thing now is I had lots of problems last time with this behavior where it goes to the next line, but now it's just one big string, so it doesn't really matter. It just goes further. Like here is an invisible return character, which works as well as like giving a space at the end to type in. But if you go further, then you're just at the next line, so that works perfectly. The only thing you need to do is limit the start and the end of the whole string. And going up and down, like I said, that's quite a hard thing. Like that, but it's not anymore with these like functions which transform from this string space and this line space. So I just take the cursor position, add the direction we're going in, and then moving back to this cursor position. Perfect. Like that's very clean, I think. As well, I don't know, maybe I should explain these header matches are amazing, I think. You can be very explicit on which operation you're defining. So like this is the X and Y constantly, and so if you're moving in the X to the right, then you're doing that. If you're moving in the X to the left, then you're doing that. And if you're moving up and down in the Y, then we can describe those both in one line. You're doing that. This is just taking the line of the whole string and then multiplying it by going up or not. Actually, maybe that's the problem because I'm multiplying with -1. I'm not sure, but I'll look into that later. Yeah, and here we have those functions which transform. I don't really like this one yet. I feel it's a bit messy, but it's doing a whole bunch of stuff where it's just cutting lines, finding enters, and then returning to you where it is in relation to all the enters. And the cursor I think this is a very funny function. I hope it's big enough. VS Code remembers which character spot you sorry, like I said, I'm dyslexic. You're at in line when you go up. Yeah, I saw that. Even when you go to short line. Yeah, I saw that. When you are at the end of a line, I think that's what you mean, and you go up, it'll remember that you were that far, and if you go up, it'll try to go that far, but it's limited. I think that is a nice thing to add, yeah, because it does make sense, I think, if you're that far, that you want to stay that far, because now if you have a very long line and a very short line, and maybe another, so 2 short lines, or actually no, sorry. So if you have a long line, a short line, and a long line again, and you do this, then you're suddenly there, even though you might want to move up to that top right one. Now you need to go all the way there again. So yeah, that would be nice to add, I think. So you need to like store, it somewhere, because it's not kept at the cursor or text position anymore. It might be a bit hard, because I don't want to store anything. You need to pass in another piece of information then. Yeah, so, like I was saying, this I think is very funny, a funny piece of code. So what I'm doing is I'm splitting the text up in enters again. I'm attaching enters. This is a bit like redundant because I'm removing them, adding it again. There should be a split function which doesn't remove the character it's splitting on. There is probably, but I should use that one. And then I'm, from these characters, picking on the x and the y I'm giving. But I want to be able to give wrong coordinates and that it then aligns to the ends, or like the limits to the scope that it's possible to be in. So that's where the clean pick comes from. It looks at the length and then limits it, or does the minimum on that and then maximum on 0. And then you always pick from the right position. And then there it adds this character. And I don't know the history of APL. This is probably an APL, or actually probably a modern APL function even. And you can type it in BQN. That's why I used it. You can type the other way around as well. But I've used it here to, in this version where the lines are split, change the character I want to stay on to this, and then revel it, so make it flat again, and then find that character, and then using that index. So I think that's very funny, actually. So I have this messy version. Oh, so there I am. So then I have this messy version, and I'm placing an anchor there, and then I'm reveling in, and then I'm finding the anchor. And that's a very practical way to do it. Only problem is if you use that, then it's gonna break it. So don't type that. I'm not sure why you would use it. Maybe for some decorative stuff. So yeah, caveat. I should use like a very strange Unicode character nobody's gonna use, because it is a funny approach. I think it works quite well. I don't think you need to add any information. You could just not change the cursor X, like the cursor X gets replaced only if you move the cursor. So when you, because when you move up, it wants to know a new cursor position on this whole string. That's what the cursor is. It doesn't have an X and Y. It's only one index of the whole string. So that could be possible, that the cursor, in this case, represents an X and a Y, and then it can store that information. And each time I want to use it to index into the normal string, I need to convert it. But there are more cases where I need the index on the normal string. Then there are cases where I need the X and the Y. So it's more of a performance hit, but then I do have the flexibility of keeping it in this X and Y space, yeah. Yeah, that's a possible way. Yeah. So the last functions are now just line starts and line ends, just finding the start and end of the current line you're on, given the enters. The current line, so the text within the line and then the line length. Yeah, I don't even know if these are working, because I don't use these actually. I do use those a lot, so those are working. Yeah, so that's what I did with the text editor itself. It's pure now and it's functional, and I really like it because you can implement it in other things, because you can just like animate a system with these functions. Yeah, and then you have this repeat key thing. It's a very how do you say it? Assertive way to make a repeat functionality. Because normally, not on Mac now, sadly, but if you, for example, hold backspace, you're going to get this. Where it's first going to do it once, then it's going to wait, and then it's going to repeat what it did. And we're very used to that when typing. So I really wanted to reproduce that because it needs to feel natural. And it's just doing some stuff. I think this one is nice. Like, is it downtime plus delta? Otherwise it's 0. So it's always 0 when you release. And this is the first press. This is a repeat. Yeah. Just functionality to do repetition. All right, so that's the troubles. Yeah. I don't know how long the delay is actually, so I might not see it immediately. And then you've got the RaylibTextEditor, and that's the implementation of the text editor. So this you give all the messages like the font size, and the default text, which you can just give it anything the context needs to implement the thing. These are the variables you're going to give the text editor. So characters, these are the characters you're going to use. This is for the cursor. This is for selection. Oh yeah, selection is another thing. I'm going to talk about that in a second. This is for return characters. And this is the character it's going to skip to do the scoping. Then it's going to initiate the editor with a nice little small e, because in this context you can use a small variable name. Because it's in its own context. Yeah, I'm going to define the text editor and cursor, which are holding the values, and this is going to be mutated. So this is the mutation that's happening. Then an update. This I was doing for some debugging, but I'll do it later when I'm going to work on some. I should actually talk about what I'm going to work on. I'm going to do that now. Sorry that I didn't before. So I have the text editor, and there are two things I want to work on. First, the implementation of the visual stuff, because that's the most interesting stuff, and it's already sort of there. If I do this, for example, and do enter, I'm gonna get a circle. Amazing. So it's just given the coordinates it's gonna use to draw the circle. And that's going to be really fun working on this. Oh, no, it's, yeah, okay. And I really want to think about how I want to structure that, make functions for that, make it intuitive. And there are also still some text editor stuff I want to make better. For example, like I said, a selection, because that's one of the biggest things in a text editor, that you can select text. And I have some version of that already. But not implemented yet. I can copy and paste. Apparently I can't. I wanted to say I can copy and paste. Because Raylib, apparently, thanks to Brian, I know that now, has copy and paste functions. r.clipboard.get, r.clipboard.set. So it should normally work, but I think I'm just doing it wrong because I changed the structure a bit. But yeah, it has copy and paste, but it doesn't. You can't really select any text, so it's just copying everything and then pasting at the cursor. But yeah, that's not what you want. Okay, so let's go over the RaylibEditor real quick, if that's clear enough. So I'm gonna go over the RaylibEditor real quick. So update just does the React function. That's what I call the update function, because I wanted to do some separation between the logic within the RaylibTextEditor and the logic, how you would view it from the outside or something. Some idea I had about that. So yeah, it could have just as well been called update, but I chose React for some reason. I'm not sure anymore. And then you got draw, which I got output. Also not sure anymore. And I've got get, which just returns you the current text. I'm using that to do the drawing of the circle. Okay, then this is also very funny, I think. I'm gonna close that. Maybe I'll make it a bit bigger. So here I'm doing making instances of the repeat key function, a closure namespace, class or closure namespace. I created here. I'm making exactly the amount I'm using underneath. And then each time you're calling do, you're getting one, and then you're rotating it. So it's just a very lazy way. It's just a very lazy way to do multiple instances and not have to deal with multiple names. Yeah, cool, Brian. I know your example on the clipboard I used, or it's Brian's first example in RaylibQN was with the clipboard, and I didn't know I was trying to do FFI or SH calls to the system, and it was very messy. And then he was like, I have an example there. I was like, why don't I look at the example? So yeah. So I'm creating 7 repeat keys, and these are the timings. And then within this, I'm doing repeats.do, and it's going to use 1 repeat key and then like a, how did I call it? Like a revolver goes around the barrel. Yeah. Okay, so I'm typing. Typing is just seeing if I press the character. If the character is add or is null, then I'm not going to type. So this is, like I said before. The repeats, if you give it 0, it's not going to be called. And if you give it 1, it's going to be called. So it's like an if statement, a very nice inline minimal BQNE if statement. So it's saying if I got an add, then I'm not going to do anything. Otherwise, I'm going to do something. And I need to swap here because this has a bit of a BQN quirk. I think more people know that. I think I already also said it last time. So if you use if you use the modifier when you call it monadically, let's see, this should work, right? It's gonna, actually I'm gonna do this. Then the right argument is going to be the main argument, of course. So how I imagine is you take the x and you take it all the way there. That's what the arrow shows. And then go through it again and then put it back into the x. So it itself goes to the right, goes through the function and then gets put into itself. And it gets updated by the function, yeah. But if you do another variable here, then suddenly x becomes the right variable. And visually, that sort of makes sense here because this is the right argument to the function. So you can intuit that it's the right one. But it does have, like, I did find it hard to intuit because it swaps it around. Like, things aren't the same in different contexts, if you know what I mean. And the problem mostly is that when you're updating something with this modifier or change or modify, your right hand of this thing is going to be a parameter and your left hand is going to be the main data. But BQN works the best when your main data is on the right of a function and the extra data is on the left, because the W argument is like an optional argument. So first I swapped all the text editor functions around so that the main data is on the left and the others are on the right, but that's like not idiomatic. So the other way to do it is to just swap the input. Where am I? So use this, swap the inputs around so that the arguments are right again. But that's a bit annoying that you need to, because then this one is pointing to the left. It's pointing to this, even though it's actually referring to this, because it's swapped around. But that would be true anyway if you swapped it around. So yeah, it's a bit of a, but yeah, that's the nature of something like this, which is extremely dynamic. And that's what I think is very pretty about it. It makes your code very dynamic. It takes stuff and then adds it to the right and then moves it down. And it's like phew, magic. It goes everywhere. I think I really like it aesthetically. But it has that problem, yeah. So that's why I'm using the swap everywhere. Yeah. So yeah, the tapping a backspace is backspace down and then also a do in between, which is gonna nullify it or not. I mean, make it 0 or not. and then doing that, the backspace, tab, enter, and they are all modifying the T and the C again with this modification. So each time this T and C, which is a local variable inside of this React scope, is going to be modified in the chain. Yeah, and then this direction stuff, this is everything to do with the arrows, and that's quite a lot. So we're doing swapping, scoping, bounding, and moving. And even when you're doing Alt and left and you're swapping, actually what happens if I do Alt and left and go up? Oh no, I broke something. Oh, I'm selecting something. Okay. Oh, it's gonna be that. That's actually what I want. Okay, nice. Yeah, and then this is the copy pasta with this key down, control, command C, command V, or control. Or yeah, this wouldn't work on Windows. Yeah, so there should be a Windows version or something, if this is gonna be more public. Normally I do is down left or is down C, but in BQN you just do is down on both of them, and then are they all true? That's lovely. And then yeah, setting and getting, then drawing, which is also specific to RaylibQN. So let's be done there, and that is, I think, it. Yeah, and lastly, when you are pressing the super key and enter, that's what I use for running the code. Then it's gonna go do interpret the text you have as BQN. See if it runs. If not, it's gonna say invalid. And if it's not, this is a bit like ad hoc. If it's not invalid, then it's gonna return. It's gonna do it in a res, which is like the result or something. I don't know. And then I'm gonna draw the ellipse with these arguments, and if that's not gonna run, it's just gonna say wrong input. I can maybe show this so I can see it in the. I don't know if it's just gonna say wrong input. I don't know if this function actually returns anything. I don't think so. I can look that up actually. Ellipse. Is it returning something? Oh, this is not. Verify the draw ellipse. Does this return something? This is going to be rabbit hole. I'm not sure. I should structure it other differently anyways. Okay, I think we're there. Maybe only explain this. This is a very ugly way of making, doing syntax highlighting. I did that for I made a particle system with the BQN characters. Actually, maybe I have that. Share particle system jars. Nope, not working because maybe this is an easy fix. No. Where is this located? Particles, games, my work. Particles, games, and then raid BQN. Particles, games, raid BQN slash. Oh, is this an error? It's an error. Yeah. I think all draw functions return null. Yeah. So I thought it doesn't really, it's only a side effect. Ray.get frame. Yeah, not sure. Maybe Brian can help me out here in a sec. But yeah, I just wanted to show you that. So I made the syntax highlighting by listing out all the characters, saying how many have a certain amount of colors, and then replicating that color that amount of times. And they've got a list of each character corresponding to a copy of each color. And then you can do call with a character and an index, and it's gonna pick that color from the index because it's just doing a match and then a slash. And I can actually turn it on if you want to see. Draw characters, X, Y, draw char, color. So if I change this to call char, Does not work, does not work. Assignment mismatched, RGBA, oh yeah, because my colors don't have an alpha channel. So afterwards I need to append 255, I think it is. To 25, I always forget. Oh. No. I think the problem is that it's a dark mode font. So I should also make the background white, black. Or, yeah, black. Yeah, so now it has some color highlighting, and like pick and all these functions have nice colors. Actually looks quite good. Only thing is, of course, it doesn't do any nesting logic, any nesting coloring or any function coloring, stuff like that. Actually, maybe I'd leave it on. It looks quite, it's not my preferred font. I really prefer the VS Code font. I think it looks very pretty. But I think it looks cool. I mean, CBQN updates. Sorry. F5 function in a reason BQN update. All right, I'll have 5 functions in a reason BQN update. Take a list, not a null. That's probably it. I meant CBQN update. Oh, in the CBQN update. Maybe we can make it work, because I do think it's a cool example. So all the ads, probably not all, but most of them are replaced by this. This one, yeah. This one, no. We might as well. Do we might as well? This one, yeah. This one, yeah. Yeah, yeah. Might as well. Wait. I just changed those, but these are my own functions, I think. Attractor update. It doesn't even use a parameter, so it doesn't really matter. Okay. Yeah. Yeah. No, not necessarily. My own function, but okay. Okay. Is it good now? Are you going to behave? It is good. Nice, nice. Look at this. Whoa. Okay, space isn't working. Maybe I can do this. Okay, it is changing when I'm resizing. It is very messy though. But look at all those nice little characters. Oh, thank you for the syntax highlighting. Yeah. So I already had this mapped out. Oh, yeah, I like it. I already had the text, so it was just a matter of putting it in there. Nice, nice. Okay, so Brian, you're gonna say what I'm gonna do if you want. Am I gonna work more in the text editor, namely selecting and stuff, or am I gonna do? Actually, I think I want to do the drawing of stuff, because that's like the main point of a live coder, you know. Okay, so as you can see, what I'm doing now is just an ellipse takes a two-dimensional array of 2 coordinates, which is the top left and the top and the bottom right. And that's what I'm inputting here. I'm doing this import here because I just wanted to give it some helper functions, and then I can get something in this context. But I don't really need it now. So I can make the default string just a space. I'm not sure if a fully empty thing works. So just to be sure, I'm doing a space. Okay, I'm gonna make the background, sorry, this is a simple aesthetic thing, but a bit lighter. Like 80. It's a bit better. Maybe a bit less. Let's do an ugly way. Very messy. Oh, it needs to round then. Or floor. Oh. Yeah. Perfect code. Perfect. Okay. Okay, so we're gonna think about the shapes. what are the shapes we can draw? We have ellipses, triangles, textures, and that's a big part of what I want to do, is doing pixel stuff. But we're first gonna do some shapes. Text is also a cool one. Rectangle is, no, an ellipse is like a rounded off rectangle. So let's see. Let's just collect them all here. Rectangles, ellipses, ellipse with outline. Not sure if I want to use that yet. Triangle. Must be very cool for you, Brian, to see someone working with this, I guess. And a line. Forgetting the line. Line. Let's see. So, actually, for 1 second, I want to see how many people are watching. Sorry, 1 second. If this works. And what I was thinking for this, okay, yeah, cool. So what I want to do is to make it, oh yeah, of course. Actually, let's just do this. That should work. Thanks. What's up? Rectangle, it doesn't know them because they're in R, actually in draw. Draw. D dots. Okay, nice. What I want to show, sorry. What I want to do, is to make easy functions to do like the string or the function, which makes you define like what you want to draw. So for example, I want to draw triangles. So then you do t's. So it's like a t function, which transforms any standard type of shape of data, like a left and a right, and then transforms that into a triangle. But you could also do the other way around, where you keep the specific data types, which makes more sense because they all have different shapes of data it needs to draw. And then you make the functions work on each one of them. Because you can do easy header matching if you have a function and then you just say like, oh, is it a D with some data, then you're gonna do stuff on it. So then it's like an array of data and an identifier, which makes it like it know how to operate on the data. And this function, for example, would be morph or LFO or like wiggle with a W or a capital then. So now you've got a wiggle function. You can put any type of data in there, and then it's going to do the same behavior, but defined for each thing differently because of the specific differences. But probably BQN is cool enough to not even care about that because it's rank polymorphic. You can just use any shape of data and it will operate on it. So yeah, so wiggle is one example where you can just draw a thing, then make it wiggle through the function, like zoom or something. This is just random beginning stuff. I'm just gonna implement it, see what it does, then see what's fun after that. So I'm gonna start off simple. Zoom is gonna take shapes. Let's see. This is very fun to watch. Thank you. So if you can think of any other behaviors or like things can do, it's fun if you say them. Things wiggle, things zoom, things rotate, things this feels a bit childish, but like maybe it's cool to show an example of a live coder, a very famous one. I've actually got this thing for live coding. Where is it? Oh, here. Oh, it's the green one. Live visuals. I've got a bunch of live coding examples. One is BQN80. For short things, just as output. It outputs pixels, which is very nice. This is very nice. This, you give it some special K. What was it? This was by oh, I should remember. It's Special K. Yeah, I should remember his name. He's a very. He was on the RaylibQM podcast, and he made very cool stuff, visual stuff, and it really inspired me. So this takes some K. I think it's his version of K or something like that, and then outputs. Maybe it's even GOSL, but I think this one is actually GOSL, or it's the other way around. I think this is GOSL, yeah, it looks like GOSL with uniforms. So it's translating them to shader language, and shader language works on GPU, so it becomes very powerful. And it is a limited version of K, but it has like super awesome examples, like, kapow, look at this. That is sick. Absolutely sick. And cursor, yeah, lots of cool stuff. And here you can type this very concise code, Mandelbrot, of course. Type this very concise code, and then it will generate this more ugly verbose code. Dagger is very cool, also by him, but it's different. And he also made Ike, which is, I think, not GLSL, but it's for making graphics. Also a sort of live coder. He said he was inspired by live coding, I think. It's probably an even cooler example. Like Snake. Spin. Spin is also very cool. Okay, and then we've got more like not Raylib, or I mean array language types of things. Orca is very cool. I don't know how to use it, but you type in characters and they start shooting out things, reacting to things, and it's very awesome. It's, yeah, I wish I could show. Is there a, I should look it up on YouTube. Oh. Orca. Oh, yeah, of course. Live coding. Yeah. Ooh. I don't know if the audio is even going through. Oh, that was scary. Let's see if he had something. So you see, it's a 2D grid, and it is essentially a MIDI controller. So you create these types of 2D circuits, and they react and respond, and then you can like make sequences and beats, and it's very awesome. Yeah, that's Orca. Mercury is a live audio tool made by someone I know, actually. Oh, you did hear the video, nice. And Hydra, that's the one I actually mostly wanted to show. This is like one of the most famous live coding tools. So you have your code here, and it's custom, I think a custom language. Then you've got your visuals there. And the way it operates is it takes in some, it has functions which generate data, and then functions which modify data. So OSC creates run. What's the run again? Wah! Control Shift Enter. Oh yeah. OSC I think means oscillate. Yeah, we can get an example. Wah! Yeah, here's, whoa, this is mouse based, so it's more clear. Maybe OSC is, the way I know it, OSC generates a wave pattern visually, like in pixels. It oscillates pixels all over the screen. And then it has all these functions like kaleidoscope it, color it, rotate it, modulate it. And that's, I think, very cool. And the syntax makes it this very, you can stack them as a functional language. And this is, I think this is pure, it just takes in the data and just modifies it. So yeah, that's a big inspiration for this. Let's look at a few more examples. Blah. Lots of, ooh, this is nice. More nuanced. Oh, now it's tweaking the code. Whoa. A lot of people that get into live coding use Orca. Hydra. Woohoo! And you've of course got shader tool, I think. Shader toy. Which is used, I don't know if it's used for live coding actually, but it's used for like very cool visual experiments. and sick things like this. This is all the shaders. This is all the code. Oh my god. Yeah. That's absolutely sick. Is this all the code? I can't imagine. Ah, it has all these other scripts. Okay. Buffers. And you should know GeoSL is very different because you work from pixel space. So maybe even the opposite of how array languages write, where in array language you think about the whole thing at once and operating on all of them. Actually, maybe it's the same. But here you could write one script and each pixel is going to run that script. And all you know is the position of the pixel or the index from 0 to 1. So the position in relation to, you can get the absolute and the relative positions. And from that you can calculate all this amazing stuff. And there are lots of other features to GeoSL because it works on your GPU. Your GPU has some features for like texture things and lots of stuff. But yeah, amazing. So this is some inspiration. Yeah, and now we are here with only this. Oh, you don't hear the video, sorry. It was the wrong way around. Yeah, I don't think it matters that much. Okay, so let's make some nice little simple functions. Let's first maybe look at what types of data each function needs. So a rectangle wants a color and the top left and top right. Let's just write that down. Color, top L, top R. And that's the same for the dot ellipse. Yes, yes. And then triangle uses almost the same. It only has one more point, most probably to define all three of the points. Color, and then does, yeah, like 0.1, 0.2, 0.3, and then a line. This is probably a color. Oh, you can actually see it. It's either a color. If it's only a color, it's gonna do it together with a 1, and that is most probably the thickness. Yeah, which can be a different thing. And the thickness of a line, of course, yeah. So it's oh yeah, and the other side is a 2 points again, but that's like only the 2 points of the line, so it will draw something totally different. Color, and then optional, I don't know, optional, or maybe optional is in braces. Thickness, thick, together with 2 points, 0.1, 0.2. Okie dokie. Let's align this. Yeah, and that is what we can do in the 2D space now, and you of course can make a lot of extra stuff with that. So let's think about this. We want to be able to write a sort of function that or we want to be able to give a parameter which defines which type of shape it should have. All the draw needs to know is some type of differentiator to be able to know which function it should call. So it doesn't have to be much. You could actually carry the actual draw function with you through the whole operations, but I think that's not really necessary. But you can just give it like an identifier. Well, actually it doesn't really matter. This, if you give it a function, most probably, if I'm right, it's just going to give a pointer to the function. We can give it a function as an identifier, and then you can actually see, oh, is the type doesn't match the dot rectangle. Does that work? The dot rect. Let's test that a bit. It's very nice that you can just execute code inline. So we've got a class like a beep, and that is just a thing, which actually a namespace thingy. And then you say beep is beep. Let's see if that works. Two roles must match. This isn't a function. This creates a 2 fork or 3 fork, where it's going to do that function is going to execute it. You don't want that. You want to store beep. Can you store beep in that? You can only store namespaces, and this is a namespace of a function. So probably not. So it's probably not a good identifier. Let's test it first. No. This then also needs to be a function, and then you can't really, then it's going to be 2train again, 3train. So you do need some identifier. Conclusion. Okay, so you can just use a character or something. Like. Luckily, they're all different. So you've got a rectangle, or a ellipse, or a triangle, or a line. A rettel. And that's like the ships. Nice. And then even if we keep the same shape, you can just make a sort of identity by well, yeah, we can just match. It doesn't really matter. I think you can actually, yeah. Well, let's just do indexes. Okay, let's just try stuff out before I think too much. So if I were to create this and return it, rectangle, that means resolution, res is just going to be an R. Let's remove this default space that messes it up. D, barp. That's returning a D. Actually, maybe I should return a D in a list so I can just pick it. Interesting. Yeah, I'm showing this, but I want to see the BQN. Let's just show res D. Oh, okay. Oh yeah, that's the first try. So only when it updates, that is here. So let's just show new. Aha. D gives me back invalid because it doesn't really do anything. If I do that, I get a character of D. Nice. And I also see it's doing is down, but I actually want, because now is down is going to be called constantly when I hold it down, but I only want it to be executed once. Try beep beep beep, you assign it as an uppercase, but it, try beep and beep, you assign it as an uppercase, but use the value, of course. Aha, you're smart. So if I do beep, and assign it to make it a function, and then compare beep with beep, maybe that works. Oh, sorry. Yes, nice. Oh, I'm still getting used to the fact that you've got case sensitivity where if you do uppercase, it's going to use it as a function, and lowercase, it's using it as a value. Thank you, Brian. Yeah, I can now use this to compare. So do I want to rectangle invalid? Doesn't know it, so I should sort of import the draw functions from the same space. So if I do draw from import port, no, yeah, slash rate bqn. That's what I want to try. Rate, oh, it's at the bqn slash raylib.bqn and run that. This is annoying. Oh, I can copy actually. Copy. Invalid, doesn't know it. Paste, doesn't work. Maybe fix that real quick. T and C, probably because when I paste, I'm not swapping. That's it. Ta-doo. There you go. Oh, it has done it twice. It has done it a lot of times, it seems. How many times? Uh-oh. Oh yeah, because this also I'm now doing this thing which I said is so native to BQN, like getting the two, but actually I want one to listen to and is down and one to listen to and is pressed, because otherwise it's going to do it a lot of times. But if it's both is pressed, then it's not gonna, you need to do them exactly at the same time. So sadly this doesn't work. So we're going to do is down, super key. Then you need to parenthesize this. And then, or key dot is down, key dot v, or is, sorry, pressed. That should work. I copied nothing now, shit. Now it's gone, okay. But it should do the same here, otherwise it's just gonna copy it a lot of times. And this is then C. And I should also do it here and probably in a lot of other places. Okay, do it here. Super, and then enter. Okay, yeah, I was doing draw from import raylib bqn slash raylib.bqn. Toop. Invalid. It's annoying. I don't see the logs when it's running. Sometimes I do, sometimes I don't. So it's a big bug. Oh, I didn't copy. That's just let's type it here. Yeah, what I'm trying to do is getting the functions in there, these functions, so I can use them. I think that's way too messy. I think I should just do simple characters. You want to keep it simple in that space. Everything needs to be enclosed and like pretty. Okay, so I'm gonna draw as a rectangle this stuff. 3 points. 5, 5, 10, 10, and 5, 5 again. That's actually very small, but this should be the type of shape I want to use. So then if I run it here, so this is where it's fresh. Actually, I always want to draw it, so I would have a function. It's kind of intended, but to output from show right away, you should do term.flush after you use show. Aha! Oh, interesting. This is perfect. I want this. It's kind of intended, but to output from show right away, you should do term.flush after you use show. So to me, that sounds very much like a hassle, as in that you need to do show and flush each time you want to print something, but you would probably write the shorter version of show, or what do you recommend? Like S, which is just show, or term.flush after show. But then it should still return the argument. So it's Let's do it non-tacitly. Yeah, so show, and then save x. Oh yeah, show with x, save x, and then do term.flush with add, and then return x. So then this should work as a show. Let's see. Aha! Amazing! It works. I don't know if that's the best way, but that's perfect. I didn't know that. Hi, invalid. Ha. Oh, oops. Copilot. Hi. Toop. Toop. Nice. I love it. Okay. So I want to draw. And I want a function, a sort of draw, just call it a draw function, and that does some header matching where the data has this R, and after it, I really like this character now. I think it's very pretty. For rectangles, you want a top L and a top R. So let's do that. Yeah, shape. Actually, that's enforce the shape. So top D, top L. Sorry, Andrew Taylor. I'm not referring to Andrew Taylor. Top R. Why did I say Andrew Taylor? I never said that. It is no thing. Okay. So yeah. So now I've matched it, and there I'm safe to draw the dot rectangle. Yeah, no, I need to recompose it. Let's just call it data. Data with color, and color is also a thing actually I want to give, but let's just do orange for now. And then in any other case, just do an add. Just do nothing. I mean, no. Draw. Only one header per body allowed. Oh yeah, I need to do the dot comma. So now I'm going to do R with 2 positions. Actually, I'm not even doing anything with the function. So I want to draw the rest. And that should work, because it does any other case, doesn't do anything. So that should work. So if I do R with 2 positions, 30 and 30, 200, 200, bam. Ta-da! I love that. You just see it. Okay, let's make the other ones very quick. E for ellipse, T for triangle, L for line. And in the E case, it's exactly the same, ellipse. In the T case, triangle, it needs 3 points. But yeah, essentially you're not doing anything else here. And in the L case, it's going to do a line. Maybe we also want to pass in a color, so that's here. Color. And now we're just using a C. I'm overriding the C. I don't think that matters, because I'm not going to use it anyways. Okay, we want a rectangle from position 200 to 800 in the color. Oh yeah, now I don't have colors. I do want to import colors, or I can just do it by hand now. 80, 120, 89, 255. Give me this rectangle, please. Why don't I see it? Doesn't give an error. Can I get it? Can I make it give an error? It might be something to BQN, probably. Ah, yeah, I see the error. This should be one thing. Actually, like that. Ta-da! Whoa, I even guessed the center. I love it. Yeah, and then, so if I make this I can't click. Ellipse. Ba-da! Oh, I'm excited. The color changed. Oh, don't even know. Don't know why. I can make it a line, but then, oh, it actually works from one point to the other. And I'm not giving the thickness now. But a triangle doesn't work because it wants yet another position, which is going to be 450, 800. I'm not sure what's going to do. Wow, amazing. Okay, hold on tight. I need to go to the toilet real quick. Sorry, I'm going to be back in a sec. Very quickly. Hello, hello, I'm back. Drink a bit of water. I never understand, I think people usually on streams just break or something. I mean, like go to the toilet in between, I don't know. Okay. Brian said, oh, never mind, you use parentheses, not list. Yeah, probably comment on that I was almost doing parentheses. I mean, list notation there, which doesn't make sense. Okay, so now we can draw stuff specified by a character, or yeah, character. And this needs to be able to modify it. And it also needs to be able to be written more easily, I think. Maybe it should have some default sizes, or you can give it like a size or position, because it's very array friendly to do the points of the thing, because then you can just transform it. Maybe from a user perspective, you just want to say center or like a number from 0 to 1 to make it go in the X and Y, and the number from 0 to 2 in the Y position, and then just a shape, and then a size. But then you don't want to know what it aligns to. I'm almost writing CSS there. Not the best thing. Okay, so colors as a first thing I want to make easier. So let's see how we can get the colors from Raylib. Because Raylib's, or I think it's in constants. Orange, dark orange, yeah. I love this. Thank you, Brian. All these useful constants, like all sorts of colors. It doesn't have gray though. Why not? I want gray. It doesn't have gray. I want like black, but slightly less black. Maybe it's already in there. Maybe this you probably copied this from somewhere. I don't know. Probably from Raylib. Or you're just very good at antique white and knowing all the colors. Blanche, d'Allemand. Oh, when you press the mouse button, it automatically writes the position to the cursor. No, if you mean here, I mean in the editor, it doesn't. Sadly, I wish it did. That's why I did all these things to make moving with the keyboard easier. Because I don't know how hard it is. If you can just get the position, then you just need to know the sizes of everything, and then you can calculate the cursor position. Maybe it is doable, but I have not implemented it. It's called gray with an A. Isn't that the English and a US thingy? I don't know. I'm just like the nice dark gray. Oh, lovely. This is what I wanted. Let's use it immediately here. See that dark gray. Haha! I actually wanted it a bit darker. We can multiply it. Multiply it by 5. And oh yeah, and then we need to. Actually, I should do it here. I got this tendency to do this. No. Oh. Shubidaba. Oh. Floor it. Yo, I like it. Maybe a tiny bit. Tiny notch. Nice, nice. Okay. So yeah, we want to make it easier to draw colors. So we want to import the constant, which is here in rate BQN search. And I need to get a path to there. I already wrote a path for importing this weird function. Where is it? It's in the defaults. Sorry, I'm scrolling a lot. It's in the default text, which I'm using here, and it's commented out now. Okay, oh, this is, yeah, here it is. Oh, no. Sorry, I'm very messy now. I'm creating the editor here, but I'm giving it, I should have given it some default text. That's here, default text. That comes from a parameter in RaylibTextEditor, and that is here. There we go. So // so we start at my work. Or actually, we start outside of my work. Yeah, so we can go to rate BQN immediately. So let's make that the new default. / rate BQN / src / constants. There we can get some constants, and we need to import that. Actually, import colors as C from import the string. To do strings, you need to do double quotes. I mean quote. But invalid. .bqn invalid. Search. Constant, is it not in there? Yeah, it is. Constants. I'm probably writing it wrong again. Constants. Oh. Let's run it. Oh. Go away. Invalid. Can it say why? Because now it's this catch is just gonna return f, which is the left function. It's gonna, g is applied and the argument returns it. If an error happens when f is applied, it cancels execution. Apply g to the arguments and return, yeah, so it should, if I don't do anything here, it should return itself. Don't be there. I'm just gonna open this up. Oh, it's gonna so BQN itself is gonna return the string it got when it doesn't run. Is that correct? Let's check. Default working on a live tool. No. Sorry, I'm touching that. Oh, hello. How many? We're watching with 2. Hello. The other one isn't saying anything, but hello. I wanted to see the specifications, the BQN. What is it returning? So the left argument rate BQN gives the list. The prefixes during evaluation does returns that. During the evaluations. does, that returns that. It returns the applied thing. But if it doesn't run, then this is going to catch. You can use current error at CBQN to get the error. Aha. Very nice. But does it even create an error? Because catch is catching it, right? And if it, for me, if I get an error, the whole thing just crashes. I can try it. Current. Is it specified? Oh. Bro. macOS is very annoying in this minimization. Current error. Oh, it is not even defined here. Show current error. Oh. Show current. Oh my God, there. Okay. Show current error. Yeah, show current error. And it's crashing. Current error not currently within any. Aha. So it is used within a catch. So I can put it there. And then need to show. I'm doing that already. Aha! Amazing. So when it fails, it's going to F. And F is getting the current error, which can only be run within that. And then that's returned and given to the new thing, which actually, yeah, that's a temporary variable, and then being printed. And then this, it is going to be run because it's not invalid. But anyways, I'm getting the error. A field name C not found. Because, yeah, I'm trying to get C, but it's called color. And I wanted to rename it C, but I'm a bit too quick with that. Because first you need to get color and then change that to C. You see, bam. There you go, I got all the colors. I love it, okay. Amazing. So now we can do it a bit shorter. We want a rectangle of from 200 to 400, 200 to 800. Oh, I wanted to do the nice little character, but it doesn't work here, of course. 800, 800, and then of a color. What's a nice color? Dark lavender. Let's see what colors we have. Constants. Dark golden rod. Let's use that. And actually we can paste. Ba-da! Toop. Ha! Oh, it makes me very excited. It just runs. That's CBQ exclusive. Nice. Oh, we could also make this like dark gray or A. Ba-da! I love it. One to do. That's almost the same as the last one. Okay. I think it was probably the same as the last one because I didn't. The color was updated already. Yeah. Okay. Let's see. So we define our object here. And then we want to do some transformations. And there we want to use the functions. I was talking about the polymorphic transformation functions. One would be, for example, to zoom, I would call it, or wiggle. So ideally you would have wiggle objects. Ooh. And then it doesn't do it now, but then you'd return this wiggle object, which is wiggling. I love it. I want it. Let's just paste this here for now. The thing I just typed. Ah, it's not doing the. It's not doing the return characters. Okay. Oh, you're seeing all my files. I think that's okay. Let's just let it float. Let it float. Actually, I'm just going to do one here. Oh. So I just have the text in here. because it doesn't store anything. Let's see. So we get the shape, and we want, oh yeah, I wanted to make the wiggle function, sorry. So the wiggle function would take in, if it's a rectangle, the rectangle in the data. Let's make a namespace for the functs, for the transformers, but then a cooler name, like a more fun name. Like beautify. Oh no, it doesn't sound good. Like animate, but then in a more cool way, like make alive. Okay, and there we have all these functions like wiggle, which we export. And wiggle checks what type of shape it's getting, which could be R, E, T, or L. E, T, or L. And if they are the same, I'm going to worry about that later, but that's very easily doable. So I am I want to transform the data. Actually, now it's also having a color. I want to transform the data so that it wiggles. And wiggling, you do it in LFO, and an LFO I've written before. LFO, in not a very nice way, but a functional way, this thing. So let's place that somewhere here for now. And in LFO, it depends on time. GC, what is GC? Oh, GC, like a GC, that's just a clock. I think it's called game clock. So it's also using an external variable, a clock. So let's define it. R dot, I'm getting it from R, right? Yeah, start clock. And it is exported now, right, Brian? Raylib, oh, Raylib, start clock. Yeah, oh no, it isn't. Maybe I should update. This isn't for me exported now. I'm just gonna export it real quick. Start clock. Oh, my camera. Start clock, and then this clock is gonna be used here to get the time. And this is just some logic for getting a thing with pi and then using sine to move around it. As in, like, time goes on, and then the time is going to go through a sine function, and then you can define some. So it's going like up and down, and then it's going to be normalized from 0 to 1, and then you can define some values to make that, like, constrain that, like how big steps each time it steps, and how big the sine wave is, so how high it goes. That's what this LFO does. So we want to LFO the scale of the data. Let's be more explicit about the data. I think maybe we don't want that actually. So if we scale the whole thing, we can just multiply it, but then all the things will shrink, and it will shrink to the top left corner because that's where 0 is. So what we want to do is for 0 to be in the center of each position. And we do that by first moving everything to the 0 point, around the 0 point, and then shrinking it there and then moving it back. And let me think. The easy way to get the center point is to get the average of all the points. And that's, oh yeah, Brian is saying something. It's exported, it's just not, oh, it's exported at the top. Oh yeah, I'll make the exported everywhere so it's more clear, yeah. Okay, so I don't have to do this. Let me revert that. Actually, in the documentation of Marshall, he says, if you're nice, you're going to export it at the top. But yeah, it doesn't really matter if you do it at both places, though you need to keep in mind both things to know what you exported, but yeah. So we need to get the average position of all the data, and the average position you get by, All right, center. I actually already made this once. Center in asteroids. That's this tacit function, and I think Brian made a better function, or maybe this is the better function. So I'm deshaping the whole, right, or merging the whole thing. Interesting. Maybe I was using multi-dimensional. I am using multi-dimensional thing. Okay, so it's going to be a list of lists, right? Because if I have a 20, 20, 80, 80, and then deshape that, what am I going to get? The same thing. Same thing. What am I doing there then? Merge. Combine the array of arrays into one array. Of all elements of X must have the same rank. It's putting them in a multi-dimensional array. So this would work for a list of lists like 20, 20, 80, 80. Here it actually does something, namely putting them in a multi-dimensional array. But we already have that, so we actually don't need that, and then we don't even need these. So it's transposing the whole thing, and then getting the length of each major cell, which is the row. So transposing means every X and every Y is going to be next to each other. And then getting the length of each major cell means get the length of how many elements are in how many X's do we have, how many Y's do we have. Then we divide that by a plus scan or insert, which is the where we add all of them together. So you would say that's like you add up all of them, then you divide by the amount, and that's the average. I think, yeah, it makes sense because, but there it's rotated and there it isn't. I think you can just do center. Well, Brian is giving me code. Center this, since the average of the top and the bottom is the center. It's the average idiom. Yeah. I think I heard about that idiom. So Brian is saying plus scan, or this is insert. Plus insert divided by the length. I don't know why I'm doing the rotate. Because this should work on rows. If you, let's see, if I do 20, sorry, I need to understand it myself as well. 40, 40, and I'm doing this. What am I getting? 2 in total. What am I? 2 because, okay, if I make this 3 elements, 3, so it's doing the length of this whole thing. It's seeing it's like a list of lists, like this leading access stuff. So, okay, so it has these rows on top of each other, and then it's just gonna do the amount of rows because that's the dimension less than the whole matrix, okay? The length of, upwards, sort of, or downwards, like on the y-axis, you would say. So, okay, length of the y-axis, which is the amount of x's and y's. Yeah, so you don't have to do this. This is the same as that. And then define that by the sum of, yeah, so it's counting up each x and each y. It's going up the thing as well. That's different from, actually no, I'm saying that wrong. Plus, yeah, it's going up the thing as well. Yeah, you need this because it's what was it called? The scalar function. It doesn't do anything if it doesn't, like it needs to work on atoms. Okay, so we're there. This is the idiom to use to get the center of a shape. So let's just do that inline to make it more clear. Okay, we parenthesize this, so it's a 3 train. We have the data, we get the center, and let's make it like that. So we, no. Data, oh yeah, we can do under. lovely under. So we do the transformation, we do the operation on each, and then we reverse the transformation, so it's back in the normal place. So we LFO, and this is just giving us a number. So we need to multiply by LFO, and that needs some parameters. I hope that's reversible again. Or no, it doesn't really matter. The other part needs to be reversible. Okay, so step, let's just do 0.2, size 200, because we want it to be big. And here we do nothing. Okay. And does that work? Pop. Oh, let's get back the code we had. Oh yeah, what I also wanted to do is now the scoping and the snapping or this bounding works for moving, but it doesn't work for deleting. That's because I've written them so they calculate it, but then move the cursor. But I want them to be more general, where they just give the position it ends up. And then you can use it for the moving function and for the deletion function. So wiggle object. We're not importing wiggle yet because we need to get it from the editor too, and that's no other thing. Let's see. So let's do another line where we import animate. What's called animate, right? Yeah. From import quotes dot slash my work slash live. Actually, live coding, yeah. Coding slash editor 2.pqn double quote. That would give us the animate. And then we need to go animate.wiggle. Let's make it easier. And let's also update that here. And sorry if this makes you car sick on the movement. Okay, let's run it, and it exits because I've selected the 0. Okay, almost. Doop. The window cannot be opened twice. Oh yeah, I'm importing this, which runs all the code in there. So let's make this a separate function. And I already had that called funcs. And actually, we don't have to do that anymore. So we can just import wiggle from funcs. Then this is going to be funcs bqn, and this is going to be wiggle. Yeah, and we're using wiggle. Padap. Unidentified identifier LFO. I didn't take with me all this stuff. But then I need to import Raylib. But I think in this case, the easier thing to do is to copy the clock. And actually, all I want is the current time. I can just extract that part of the whole functionality. Time is start time minus mono time, so all we need is this. Sorry. So start clock is going to store the time, and if you get the time, it's just going to do that. Yeah, and then we're calling start clock, just like that. Oh yeah, and I need to run this. No, I need to run this, the editor. Funcs. Ta-da, wiggle. Okay, okay. And then let me see. We wanted to draw a rectangle. Oh yeah, I already had all this stuff here. Oh, don't pop. Okay, so we've got our objects in the center and we want to wiggle it. Unidentified identifier in 1. Let me give that some more space. Wiggle object. Object. I'm not storing it anymore for some reason. Object. Ba-da-ba-ba. No. Wiggle unidentified identifier. What is unidentified? Oh, no header matched argument. Wiggle. That means our funcs, this one, is not matching because I'm doing strings instead of characters. Silly me. Quotes gonna be this. Nice. Okay. Oh yeah, I need to run the editor. Do I still have it copied? Okay. Object is inverse not found. Why didn't I test this? So let's test this. This is our function, and we want this is a wiggle, another wiggle, and we are using this on some data, which we're going to define, which is 300, 300, and 800, 800, and best library ever. Yeah, bucks worth. Brian is probably listening, so let me think. And then we are wiggling, so let's show the result of that. Show another wiggle. Inverse not found yet, that was the problem. Inverse not found of another wiggle. Who is inversing? This is the only inverse, right? Under. Or is there an, no, there's no inverse anywhere else, so it should be this. It's not able to inverse this. Why is that? It's collapsing 2 times. Maybe extract it again. Divided by length. Also best language ever. This cannot be inverted. What's an easy way to test that? Turn it to that. So this gives us the size, or the center. And if I just don't do anything and then move it back to what it was, also inverse not found. So something about this it doesn't want to invert. And maybe that makes sense because what I'm returning, I'm collapsing it. Why am I inversing it actually? Because I want the data in the same structure. Aha. I'm getting that value. Yeah, I don't even want to invert. That's the problem. So I want to calculate this. That's true. And then use it as center. See, it has so many meanings. Actually, let's make this nothing. So we know we're not doing anything with it. So we want to calculate the center, and then we want to subtract data or center from data. Yeah, data minus center, but then the other way around. And then we have the center, and then we want to multiply this data by the center. And then afterwards, add the center again. That is what we want to do. We don't want to invert anything. Yeah, I hope that works. We want to run the editor. Oh yeah, and now I need to, oof, there it goes. We want to copy this again. And then run this. then go there, paste it, and run this. Boop. And it's giving us some data, but it's not drawing, because when I run it, then it's going to calculate wiggle, but it's not updating, of course, because what I run is once. That's an interesting thing. And what I'm getting is way too big, so wiggle is wiggling way too much. And I want to be able to give some parameters as well. Let's make this the default part of it, so I don't have to type it each time. BQN, and then objects, wiggle object, yeah. So these are some bit more reasonable. It's not drawing anything, probably because what I'm giving back is not the whole structure anymore. It's just the data, and I also want this R with that with the color. So I do want to keep the color. Yes, yes. Now, oh, it's giving an error. Redefinition of what? C. Yeah, that's, yeah. I'm using C as center and as color. Center, or maybe make it more explicit here. Color, and I use color there. Doop, haha. So if I keep running it, it's working, which is lovely. It's growing way too big. Let's fix that real quick. This size we just want to make 1.5. Yeah. Wow, look at that! We're getting something. Only problem is it's only running when I'm typing. I mean when I run it, because then it's going to calculate everything. So what are we going to do about that? We want maybe also only to just give it back strings which define which modifier functions it's going to use. And then the code itself is going to use those functions. So I'm just giving it the name of the modification. And then editor is going to go in wiggle and run wiggle each time, just like we're doing with draw. I think that's a good idea. So we do want draw in there, or let's keep it separate but import it at the top. Wiggle from /funcs.bqn. There we go, wiggle. And then when we draw, before drawing, we want to update. Let's do it for like this for now. So we don't actually, just to test, we don't actually have to do this. Oh. Okay, let's do it with the keyboard. Don't do that, and we don't do that. We just give it back the rectangle. We run it. Oh, there's no enter in between. Enter in between. Run it, and it crashes. No header matched argument in what function? BQN 17. Oh, sorry. 17 character type. This is it's typing. It's trying to type the data. Interesting. Why is it trying to type the data? This is a very interesting bug. So a function where it gets the data and the color, that's on live coding 17. That's in my local, yeah, that's inside of, no, it's not. editor BQN there, no header matched argument in live coding / line code. No header matched argument. Data, wiggle data, rectangle. So wiggle, aha, I'm moving data through there, but I'm returning R and C again, but rectangle wants only the data. So what I was changing before, here I can remove again. Because now it's only changing the data and not the whole thing. Let's run that. Okay, let's run it. Ta-da! No, it crashes. No header matched argument again. In live coding 17, I think that they mean this thing. L, yeah, that's what it's trying to find, because nothing is matching this, because again, it's matching on this type of data, but it only wants just the data. So it's like the fallback that is hanging on. Wow, look at that. It's still very sluggish for some reason, even though this runs fine. That's probably due to something else. But it is being visual. That is true. Let's see. Step and the size. Steps are probably too big. Oh, it's even worse now. Steps should be bigger. Okay, sort of going smooth. Let's make the size a bit bigger. And actually I want to, yeah, let's do it for like this for now. Oh. Okay, it's going down and up. I'm really starting to like it. Oh, sorry. Okay. But now we're always doing wiggle, but we want to be able to define what functions, what modifications we use. The easiest way to do that is to do the same as with the shape it uses. Also just give characters for like a W for wiggle. And we can start out like that, but that's very messy. We could also just define functions like wiggle and make that equal to W, and then we can, or actually which takes the shape, or like shape, data, color, and then return shape, data, color, shape, data, color, like that, and then we have that attached to the information, but then the shape is different each time. So actually we want a place to store all the functions, all the operations we want to do, which are chained, so we can just make a list, which is always part of it, and I'll put it at the end. And if there's nothing in there, it's just not going to do anything, and otherwise it's and actually then this is nice. So we take this list functions and we append the new functions to which is wiggle, and then you will get a list of characters, actually string, and each character represents a certain operation you want to do. Without any parameters now, that's going to be a problem in the future, but step by step by step. Okay, so actually I don't, it's a bit silly to do that. Let's just type it in there. And actually let's just make this a string, so you can just type each operation in there. And yeah, no, it's not doing anything, of course. So you want in draw, before we go to draw, to move it through this these operations. The operations we can list again. Wiggle is one of them. So actually like operate or like transform, where we match on the character wiggle, and then we return that function. So it's like a map to the correct functions. And yeah, we only have one now. Otherwise, don't do anything. That's returning the function, and then what we want to do is for the actually those are defined there. For the data which we get in, which is the it's the res for some reason. The res goes through the transform, but that like each result, what I give back should be a list of objects I want to draw. We go over each of them. They go through the transforms, and now it only gives back functions, but actually you want to take one of these results, which is some name, some data, some color, and then with the corresponding function, but actually it's a string of functions. So that's not what we want. We want to then match on each individual function. So, sorry, I'm going here. Before we do any of this is actually the wrong type of brackets. Before we do any of this, we are going to take our, let's call it an object, and we are going to decompose it so that we have nothing, or actually data we want, data, nothing, and our functions, object, and then we're gonna go through each function. Each functions, no one funcs, and then each function we're gonna match so that we can match on individual characters because it's a string. So if it's a wiggle, then take the data, transform it with wiggle, kadambam. Okay, and then each function is gonna grab a new thing, and then it's gonna be in order manipulated. And now let's just also define a nothing where we don't have anything. Actually, I don't think that's even possible, because then it needs to be a part of the string and able to be here in order to be there. So this should work. We can only transfer or wiggle now, but we take the results and we decompose. We get the functions and the data, and we transform all the data, and then we should then give it back in the same order. So the object, but then with the data changed, and not only the data changed. So then we do need to unpack it. Let's just actually unpack it. So this is the type. I think I called it different earlier, but okay. And the color. So then we return a color, then the transform data, which is the data because it's modifying itself, the color and the funcs. And maybe we can even drop the funcs because we're done with functions, so we don't need that information anymore. And then after that we're drawing this. Yeah, it doesn't have functions, so that should work. Let's delete the beep boop, delete that actually. Yeah. So we're getting the data, then transforming them and drawing them. Let's do that after we've defined that. And we're transforming it with wiggle, and wiggle we've imported at the top, and that's our funcs. So let's run it, and we get an error. Mismatch type, spread assignment. I need to go. Friends asking to hang out. Yeah, of course. Been super cool to watch through. Made good progress. Good luck. Thank you, Brian. thanks a lot for watching. Cool that you're here and that you helped. I don't know how much longer I will be, but I'm in the flow now. So, but good luck with your friends. Have fun. I mean, have fun with your friends. Okay. And then that, yeah, we're drawing that. And this we can actually remove. Maybe it's nice to, yeah, it's nice to keep that though. Okay. We got an error. And the error is mismatch shape type of assignment, and because object probably is something else, let's print object. Oh yeah, because now object starts out as this, but actually you want a list of these things already. Actually just an empty list. Because we're going to go over each and there's nothing in there. And then we are drawing an empty list. Actually, we want to do each on that as well. Okay, that shouldn't crash. Now we got an object and we're returning a list of objects. So that's a list, object. Oh, crash. 17, object into this thing, mismatch spread assignment. Wasn't I printing it? No. Show. Oh, wait, I need to, enlist that again. Oh. Actually, I don't even have to do anything there. Oh yeah, now I'm not doing the functions. Wiggle. It is doing something. It is doing a lot of things. It's just not drawing. Where is my show? There it is. So we want to see why it's not drawing. So we want to see what it's drawing. It's doing this still. That's probably what's messing it up. Let's make the default different again, so I don't have to type it each time. Crashing. Mismatched shape for spread assignment. Functions, object. This is, it's actually showing what it's giving. Oh yeah, it doesn't again have the functions because I didn't write that. Okay. Okay, it is working, but it's not drawing anything. Show. Let's see, I'm not printing. Transform, draw, rest. Let's see what it's after the transform. Ooh, so. Well, that looks cool. So the sizes are okay. This should be the function, but it's now a color. That's probably the problem. And it's enlisted once too much, I think. So quite a few problems. Transform takes, I'm not giving it I'm giving color. That's literally a problem. I'm giving that back as a list, and it's going over each. Oh, it's already working. Never mind. Look at that. And now this W determines what type of operation we're doing on it. So to make that cooler, let's make another operation in funcs. Maybe let's call it operations then. Operations. Operations. Where is it? Oh yeah. Operations. Okay, wiggle. We got wiggle. Oh yeah, now only a rectangle can wiggle, but that's fine. And it's not matching anymore, so okay. Problem for later. What's another shared thing we wanted to do? We already had this list. I removed the list. Want it to wiggle, rotate would be cool, but I think that's a bit hard to do quickly. We can make it scale, like maybe, yeah, like bounce, like zoom, zoom, zoom. I think that's cool. And I think I also need to end after that. So this is the last function I'm gonna make because it is for me quite late. Oh, no one is even watching, but probably later. So flex, let's call it flex. Sounds cool. We're getting the data. And then we return back the data transformed. Flex means, let's do the same thing. This is also a bit ugly. I'm gonna make that better later. So we want to get the center again, which is that idiom, the plus scan divided by the length. And then we're subtracting the data from that again. That's like a thing I'm always doing, so I should probably make that a function or something. So now we've got it in the center where we want it, and then we want to scale on the different axes, but then like offset from each other in a certain different pace. So we sort of want two LFOs. Yeah, we want to take the two different parts and scale them separate from each other. So we should do that with an under, so we can reconstruct it after that. We should pick both x's and both y's, which is like pick the major cells, but then over the major cells. Does that work? Let's try it out. So 20, 80, oh, or let's do 20, 20, and 80, 80. And we want to grab the 20 and the 80 together. So if we normally do that, we're getting 20, 20, but we want to do it like that, yeah. Picking, or like, what's this name again? Select first cell of the major cell. So then we have the x's and the y's separately. And then we want to LFO each one of them. So just do an LFO, but they both need to be different LFOs, because now it's just going to do the function on both of them. We want to first separate them. Yeah, because after that, let's return this. We get, yeah, we want to do that for that and for the one pick, and then combine them. Oh, yeah, and then we have both, but not combine them and list them. Then we have them separately. Then we go over them, sort of, I think. Let me think. So we want to then scale on the x, scale on the y. I think the easier thing to do is actually have two values, like 2 and 8, and then multiply this thing by those two values on the x and the y. And I think if I transpose this, it's going to do those separately. So yeah, the x's are quite like not that much bigger, and the y's are much bigger. You can see it here. So this is working. So we want to transpose it, so we get the ones and the positions we want, and then multiply it by two LFOs in a list with these parameters. These were nice. LFO with these parameters, but these values should be a tiny bit different. So we are multiplying by that, and then it's going to be retransposed or put back, and that should actually be it. That should be our flex function. And now if we also define flex here, as f, and do flex the data, which we import from wiggle from operations, and run this. It's not liking it because at line 177 we are not doing a dot comma or a semicolon, and it doesn't like to import flex because flex line 2 import operations. Oh wait, sorry, it's giving an error here. Empty statement or expression. Oh yeah, it's doing that. Let's just match on nothing and don't do anything then. On invalid undo header. That. Why is that an undo? Is it trying to combine multiple things? This should be bound together, and then this should be bound to that with an undo, and then the rest shouldn't be. Invalid undo header syntax. Oh, I don't see why it's pointing to that. 22, yeah. Subtract the opposite sides. What is the data after that? Maybe it's not print. Oh wait. Only one header per body allowed. Ah. Oh yeah, I changed that and didn't test yet. This is wrong. No. Oh, okay, now it's running. Okay, that's wiggle. Now we have what was it? I forgot. Flex. Flex. Okay. Aha, yeah. And after I've done all that, I need to move it back. So C plus. But up. Oh yeah, and then flex. Whoop. Wow. I actually imagined it to be a lot more subtle and don't shrink totally. Don't totally shrink. Let's remove the print or as show. And this freezes if I don't clear it. Okay. So we want to limit it? No, we want to scale it up afterwards. So multiply by, and this is all not generic, I'm going to do that later, 500. Oh. Whoa. Yeah, because these are still very big. I need to be very small. The party too. Okay. Doesn't like that because I've done 2 dots. And I need to run this. And I need to again do F. Still too big. Most probably because of this multiplication, which is way too big. Let's do 200. And F. Okay. Very slow. Oh yeah, because I'm also scaling down step. But step is the size or the speed. So this needs to be bigger. I want it to wiggle nice and at a good speed. Oh yeah, because it's still going to 0, it should add the value. Okay, it's now here down in the corner. Why? Because I'm scaling it down. It's very small now. I think, yeah. And then I'm adding the position, but I'm not making it bigger afterwards. So plus is not scaling it up, but it's moving it. But if I scale it up, it's still going to exaggerate what it's doing. So what I want to do is to make the LFOs have some default offsets, like 80. Oh, snips. 80, 80. Oh, snips. Yeah, and then this I shouldn't do. I shan't do. Interesting. I don't think. Okay, yeah. When I'm done with this one, I'm gonna stop streaming. But it has been really fun, and I think I've made a lot of progress. Was in a good flow. So let's finish it nicely. So the LFO is giving back a single value, going down and up. And when I add a value to it, it should be doing this like if it's from 0 to, or from -0, from -1 to 1, and if I add 80 to it, it should be from 97 to 81 constantly. That's what I want. Then I'm wiggling in a higher position. That's why I'm adding 80. And that should work. I don't know why it's not. Maybe I didn't save. Because now it's very big. And it shouldn't be very big. Because all I'm doing is I'm multiplying the size by that. Yeah. So I should, because of that should still work. That should still work. Let's make it smaller to see what's going on. 30, 30. Even smaller. 3. Oh. No. Strange. The center plus. And if I remove that, is it gonna behave again? Oh, snips. It is being scaled up because of this number. Because maybe I'm giving a left-hand argument LFO? No, I'm not. I am also adding, so it doesn't make sense. Oh. Heel strange. Very strange. Multiplying the data, which are the positions, from the center, which already has a size, by an LFO means by a value that is going up and down. That means it should scale that amount. LFO is just giving back a number. This is doing that. Let's do a dummy real quick. 40. Oh. And this I am LFO. Actually, no. I am doing this whole thing where I'm transposing under a multiplication of a list where we have two numbers. Yeah, and that should scale up these two numbers, like wiggle the two numbers. And that is happening quite finely. But now if I add 2, yeah, it's gonna become even bigger. I'm getting that now. Yeah, I already got that, I think, but yeah. So it's a value which oscillates then even more. It should be offset. What if I just make this way smaller, like 0.5, and then add like 5. And the 0, 0, 5, 5, and add 2. What's going on then? Broda. Why? Or am I changing? I'm changing the step. I want to change the size. So this should be even smaller. Even smaller. Now, 1 should not do anything. If somebody can help me, oh, no one is looking. If somebody could. Why isn't this working? I'm then adding C again, so pasting it back. So this should just be the data. This is just put to the center of the shape, or moved to the center of the shape, multiplied. I cannot add because then it doesn't add equally over all the points, so I should multiply. And I should only multiply by a number, but then it needs to be offset. And the value is added afterwards. What if I subtract? No, I don't think that matters much. This looks like a gun, like a spaceship, like an epic spaceship, with all these elements. I'm hammering on this because I want it to work when I end. I don't want to just end now. So sorry for my girlfriend who's waiting. I'm very sorry. I'm gonna be home soon. LFO 2 plus. That is the step, and that is the size, and that is very small, so it should be very nice. Maybe I should shrink the actual size a bit. I mean, this value, this 200, 800, because it's already very big. That might be the problem. So that's what I'm gonna try and stick with. So it's going to be 400. So we added 2 and we subtract 2 here, 600. And I'm going to change this to F so I don't have to do it each time. Okay, looking like something good. 5. Oh yeah, and this is now way too small. Yeah. Actually, I think these just need to be way more conservative. This can be a lot bigger. I think that's the problem. I'm seeing them as positions, but they should be like, okay. Make it way quicker. Make it quick, boy. Let's see what that does. Okay, it's sort of breathing. It is doing something. So I could, editor 2, unused, unclosed quote. Wuff. Aha. Yeah. Because this is a string. Yeah, this should be a string. Oh yeah, then string needs to be double quotes. So what I wanted to show is I could actually do F and W, and that's gonna wiggle and fold. So it's wiggle and flop together. Later I'm gonna also do parameters, but yeah, I am very much getting somewhere, and I think this is a very nice place. And I'm starting to understand why it didn't work. And we're getting some live coding capabilities. So I'm gonna And then finish it there. We have no one left watching, but we did get quite a lot of people watching, more than last time, because I shared it. And Brian was very nice to have here, because he helped me a lot. And yeah, it's fun to sort of do co-creations here. Yeah, thanks a lot. Let me see what I can do to end it. Yeah, okay. Thanks a lot for watching. I'm gonna go sleep. It's been a pleasure, and see you in the